The experiment was designed initially in the mid-'80s and has taken this long to construct. There are 10,000 people of over 100 nationalities. That includes countries which are mortal enemies of each other, like India and Pakistan and Georgia and Russia and Iran and Israel, all have physicists working on this machine. These big blue things are 7-ton superconducting magnets, which have to be cooled with liquid helium to the coldest temperatures on Earth, colder than empty space. There are 100,000 computers connected all over the world to deal with the data. In fact, the World Wide Web was invented at CERN so that physicists all over the planet could share the data.
So the LHC is basically the most fundamental of experiments. It's like what any child would design as an experiment. You take two things and you smash them together. And you get a lot of stuff that comes out of that collision, and you try to understand that stuff. Now, in this case, what we're smashing together is tiny protons, which are inside the center of every atom. And in order to get them going as fast as possible, we have to build this huge 17-mile ring. And we run those protons around the ring multiple times to build up speed, almost to the speed of light. And then we collide two beams going in opposite directions at 4 points. And at those 4 points are 4 different experiments: ATLAS, LHCb, CMS, and ELISE. Now I work on the ATLAS experiment. And ATLAS is like a huge 7-story camera that takes a snapshot of every single collision. And that's billions of collisions. And the hope is that we'll see the very famous Higgs particle. But every time we've turned on a new accelerator at a higher energy, we've always been surprised. So the real hope is that we'll see the Higgs, but that there's also something amazingly new.
We study particles because just after the Big Bang, all there was particles. And they carry the information about how our universe started and how it got to be the way it is, and its future. At the beginning of the 1900s, it became clear that all known matter, everything that we know about, is made of atoms. And that atoms are made of just 3 particles: the electron, the proton, and the neutron. In the 30s, other particles were discovered. And by the 1960s, there were hundreds of new particles, with a new particle discovered every week. And there was mass confusion. Until a number of theorists realized that there was a simple mathematical structure that explained all of this. That most of these particles were made of the same 3 little bits we call quarks, and that there are only a handful of truly fundamental particles which all fit together in a nice, neat pattern. And there was born the Standard Model. Eventually, all the particles in the theory were discovered, except one, the Higgs. And the Higgs is unlike any other particle. It's the linchpin of the Standard Model. Its theory was written down in the 1960s by Peter Higgs and a number of other theorists. We believe it is the crucial piece responsible for holding matter together. It is connected to a field which fills all of space and which gives particles like the electron mass and allowed them to get caught in atoms, and thus is responsible for the creation of atoms, molecules, planets, and people. Without the Higgs, life as we know it wouldn't exist. But to prove that it's true, we have to smash particles together at high enough energy to disturb the field and create a Higgs particle. If the Higgs exists, the LHC is the machine that will discover it.
I can remember walking in and just being like, just stunned. I mean, me stunned, already kind of having an idea of the magnitude. People tell you, oh, it's 5 stories tall. And you go, oh, okay, 5 stories tall. And then you see 5
stories completely filled with microelectronics. All custom designed, all hand soldered. You know, it's like as if it's a 5-story Swiss watch.